Main or high-pressure steam for the Mitsubishi steam turbine is supplied by one or both of the two Hercigs. The amount of steam required depends on the desired generation from the steam turbine generator. Steam travels along the main steam line to the HP steam bypass to cold reheat piping intersection. Under startup or trip conditions, the steam may be bypassed to the cold reheat steam piping by means of a bypass valve. The HP steam bypass line is routed to the cold reheat steam piping. Bypassing steam to the cold reheat piping ensures adequate cooling flow to reheater elements during steam turbine transitions. A control valve and de-superheater conditions the pressure and temperature of the main bypass steam discharging to the cold reheat steam piping to cold reheat conditions. From the HP steam bypass to cold reheat intersection, main steam then goes to the main steam stop-check isolation valve. After the main steam isolation valve, the steam piping connects with the supply from the other Hercig and continues as a single pipe over to the steam turbine area. The main steam line divides into two branches to carry steam to each of two main steam stop valves. The stop valves, along with the main steam control valves, are enclosed in a protective housing. This housing also contains the LP stop and control valves, which will be discussed in a later segment. The main steam stop valve admits steam to the inlet of the main steam control valve. The stop valve is also used for quick and complete isolation of main steam to the steam turbine. The stop valve is slammed shut any time a trip condition occurs with the steam turbine. The main steam control valves are used to control the amount of steam flowing to the steam turbine. As increased generation is demanded, the control valves will open to admit more steam to the steam turbine in order to meet this additional load. Similarly, if load demand is reduced, the control valves will close down to admit less steam to the steam turbine. With the stop and governing valves open, steam flows to the main steam inlets on the top and bottom of the steam turbine casing. When main steam enters the high-pressure section of the turbine, it is turned and directed down the length of the turbine shaft through the first set of stationary blades. These stationary blades are also called nozzles or diaphragms. This first section of fixed turbine blades consists of a Rateau-type control nozzle. After passing through a set of fixed blades, the steam then strikes a row of rotating blades, forcing the blades to move. Each successive combination of diaphragm and rotor blading is known as a stage. After exiting the first set of turbine blades, the steam is redirected by the next set of stationary blades. The curvature of the second set of stationary blades redirects the steam flow to properly strike the next stage of rotating blades. This process is repeated through all stages of the steam turbine. The steam leaves the last stage of the high-pressure turbine and is collected by the casing and directed to two discharge pipes on the bottom of the turbine casing. At this point, the steam becomes known as cold reheat. The two cold reheat lines, which are actually two high-pressure steam exhaust pipes, merge into one common header. As the cold reheat line returns, it splits into two separate lines to the individual Hercigs. Check valves and isolation valves are located at this splitting of the steam lines. Finally, the cold reheat steam returns to the Hercig to gain more energy to become hot reheat.